And by jamming it, the signal is never received by the vehicle and the car never locks. What he's doing is that he is sniffing the CAN network. Some of these simple attacks that we're going to be showing today still work against Honda cars.
And you know that just by research, right?
Exactly.
Hey everyone, David Bumble back with Occupy the Web. If you haven't seen our previous videos, he's once again the author of this book, Linux Basics for Hackers, a fantastic book from No Starch. He's also got this book and he's busy working on some new books. Occupy the Web, welcome.
Thank you, David. Good to be back.
This is our third episode talking about Mr. Robot hacks. What have you got for us today?
There's an episode, I think it's season 1, episode 4. They go ahead and hack into a vehicle before they go to Steel Mountain. They're planning this trip to Steel Mountain to be able to get that Raspberry Pi inside of the facility, to turn up the temperature, to degrade the tapes so that E-Corp can't restore their data after they've basically encrypted all their data.
Sure you don't want to just blow it up?
But to get there, they don't have a car. They live in New York City, so they have no car. So they've got to steal a car. And let's put a caveat in here right now. This is for educational purposes only. I'm not encouraging illegal activity. This is all for educational and research purposes. We're going to look at multiple ways of stealing a vehicle like they did in the episode. And we're going to look a little bit at how to do research into car hacking. And basically what we're doing is we're combining, in essence, two of the classes that I teach. One of them is software-defined radio for hackers and car hacking. Both of those courses coming up. I got the software-defined radio hacking course coming up in mid-August and the car hacking course coming up in October. So we're going to take elements of both of those courses.
I see cars are becoming more and more like computers. I don't think manufacturers have always thought about what they're doing or haven't put security in. So I'm glad that you're highlighting this because, it wasn't so easy in the old days to steal a car using software, but now it is. So I'm glad that you're doing this.
Yeah, it's obvious that the car manufacturers were not thinking about security when they first designed these. Some of these simple attacks that we're going to be showing today still work against Honda cars up to 2020, whereas some of the other manufacturers have gone to more secure systems. What we're going to be doing here is probably the attack that Mobley and Romero used on that vehicle. Let's start off by talking a little bit about software-defined radio. Software-defined radio, I think, is like one of the cutting edge fields of cybersecurity, one that people really aren't paying attention to. And if you think about it, so many things in our society are run by radio signals. And we're seeing, like, for instance, right now in the war in Ukraine, that they're using drones as a way to spy and reconnaissance for sending rockets and missiles and what have you. Of course, those drones are all run by radio signals, and now both sides are in there trying to hack and jam the radio signals from these drones. Your Wi-Fi is a radio signal, right? We all know it runs at 2.5 gigahertz and 5 gigahertz. Your phone is sending off a Bluetooth signal. It's sending off an NFC signal. It's sending, there's so many different radio signals that are controlling our lives. And not all of them, but many of them are relatively easy to hack. In the past, radio signals all had to have separate hardware. All your radios, you had separate hardware for different purposes. But now we can pick up these signals and transmit signals with very inexpensive receiver, transmitter, and then use the computer to be able to manipulate those signals. So what I'm going to start off with first is the really inexpensive, the RTL-SDR. This is a little device that you can buy on Amazon, and it's basically a receiver.
And you just plug that by USB into your laptop, right?
Exactly. So I just plug it into my laptop. All right, and it's a receiver. It works pretty good, especially if your interest is in trying to receive signals. I'm going to open it up with an application here. This is HDSDR. It's a Windows application. The reason I'm using it is because it's pretty easy to work with for a beginner. This is the waterfall down here, and we have all of the signals. See these spikes here? There's a spike here. And I've got it centered on 315 megahertz. The reason I have it centered there is because that's where the key fobs that the car manufacturers make. That's where they operate in the US and Japan. In Europe, I think they use 433.9, but I'm in the US. I'm using a US Japanese key fob. So it's going to be probably in the 315 megahertz range. One of the things that's important to note is that whenever you're working radio signals, any device that is using a part of the radio spectrum has to be registered with the FCC. So if you have a question about what frequency the device is using, all you have to do is look at the back of the device and it'll have an FCC number on it. Look it up. It'll tell you exactly what frequency it's operating at. I know that these operate at 315. So what I'm going to do, I'm going to go ahead and hit the lock and unlock on my key fob. Watch what happens right here around 315. See that spike right there?
Yep.
And you see it right here? That's the signal from my key fob. I'll do it again. There it is. That's the signal to unlock my door. See, it's centered right on it. Right. Looks like it's 315.05. You see it right there?
Yep.
315. So now we know what frequency it's operating on. What they did in the show, they're sitting on a porch step in New York City, and a woman is leaving her minivan on the street, and she locks it with her key fob remotely. There's a number of different strategies for being able to unlock this vehicle. One of them that they may have done, it works in some cases, is you can simply jam that signal. So somebody goes ahead and pushes the key fob to lock the door like I did here. You can see I've done it 3 times right there. You can see them passing by. I can jam it, and by jamming it, the signal is never received by the vehicle and the car never locks. The weakness of that strategy is that people often will listen for that beep, that little beep that says the car's locked, but some people don't. Some people just careless and they push the button and they keep going. I'm going to show you first of all how to jam the signal, and then also what we can do is to actually capture the signal and then replay it. Radio transmitters all have essentially a password in each of them. Those passwords are all different. So as they make a key fob, they put different passwords. It's basically a set of numbers, right? They don't change the password each time it's transmitted. If I can capture the signal, then I can store it and replay it. This is probably what they did in Mr. Robot. This strategy will work on Honda cars up to 2020. About 2014, the big luxury car manufacturers got a clue. So the Mercedes and the BMWs and the Lexus and a few others got a clue, and they started putting in what's called a rolling code so that the password changes each time. And that can be broken as well, but it's just harder to do. For older vehicles, okay, those before like 2014, and especially those that are in the first decade of the 21st century or older, especially on the luxury cars. So if you've got an old Mercedes sitting around, it's a good test vehicle to test out this strategy. One of the things that, going back to the Ukraine war, is that we found that in many cases that the Russians have not been encrypting their radio communication. So we've been able, the Ukrainians have, to pick up these signals because they're just sending over the airwaves, and you can just pick them up and listen into them. But you can listen into all kinds of signals with this inexpensive device on your computer. So you can listen into, say, the communication between airport control towers and planes. You can pick up the signals that the aircraft give off. You can pick up the signals that, say, boats and ships give off. All of these vehicles give off a radio signal for geolocation. When we did the geolocation of the yachts of the Russian oligarchs, the way we were able to do that is because all those ships give off a signal. they all have to give off a signal. Some of them now have turned it up, but legally they have to give off this radio signal. In the very large ships, they'll give off a GPS signal and they'll give off an ADS signal as well. So you got both of these signals that you can just simply listen in on and use them for geolocation. So lots of things that you can do with just a receiver. The whole kit is about $35. That includes, an antenna, what have you. Antennas are pretty important, so we can't ignore that. And we'll talk about more about antenna technology and theory in the SDR course, because when you're starting to talk about trying to receive very weak signals or trying to jam signals, you have to have just the right kind of antenna to be able to do that effectively. But in our case here, we're not going to, that's beyond the scope of what we're talking about here. What we're trying to do here now is we're simply going to try to jam the signal, and we're going to try to capture and replay the signal, both of which may be effective at being able to get into this car. To be able to do that, we need a different device. This right here, this $20 device, is great at receiving, but it cannot transmit. To transmit, you need a device that can transmit. and the cheapest good one is the HackRF one, and it runs about $320. I'm going to go switch over to a different piece of software and a different piece of hardware.
I've put links below to the software and the devices. So if you want to use the Amazon links, please note that there are affiliate links. So if you want to support the channel, you can buy using those links if you like.
So what I have here now is a virtual machine of an operating system called Dragon, and it's relatively new. It's specifically designed for SDR. That's all it does. I mean, it can do anything, right? It's a Linux operating system, but the beauty of it is that the developers have built much of the software that you need to do SDR, software-defined radio, into a single operating system. I should point out that there's a lot of software in this field. Probably the most commonly used piece of software in the field is SDR Sharp. There's also a Universal Radio Hacker, which is good as well. And of course, in the Linux environment, there's GQRX, which we'll be using here in a little bit. I'm not going to recommend one over the other. They're all free, which is also really nice. Now what we need to do is we're going to take that and connect our SDR device. So what we're going to do is we're going to use a piece of software that's built into Dragon OS. And Dragon OS has so much good software in it. Otherwise, you'd be spending all your time downloading different pieces of software. So what we're going to do is we're going to use a piece of software that we can use to be able to, it's Osmocom signal generator with no GUI. All right, and then let's do a -H. This is going to just show us the help screen on it. Lots of good stuff. But what we're going to do is we're going to use it for generating a jamming signal. Now we have to be close to the car. And Mr. Robot, they're sitting on a step on the street next to the car. They can see the car in the background. So they're really close to the vehicle, because one of the things if you're jamming signals is you have to have a stronger signal than the one that's being sent. One of the options also is to go out and purchase an amplifier. If you purchase an amplifier, you can send the stronger signals. Most of these inexpensive devices don't send out a very strong signal. If you're really going to jam, you probably want to use an amplifier. The device that they're using in the show, by the way, there is a company who sells those devices, and they run $10,000 to $15,000 each. All right.
Oh wow, yeah.
Yeah, so there's a company, a kind of an undercover company, who sells them online for $10,000 to $15,000 each. But essentially, what we're doing is doing the same thing, but with your laptop and a $300 device. Right? So notice here, there's a Gaussian output, generate Gaussian random output. That's what we're going to be doing. Probably the best analogy is this is like a DOS attack against a radio signal, basically throwing out random garbage at the signal to block it from ever being received by the receiver. So there's a transmitter, which is the key fob, and it's sending a signal to a receiver in the vehicle. But if something blocks it, it's never going to get to the vehicle. And it could be a physical block, or it can actually be another radio signal blocking it. So it's going to be an up arrow, and then we got to tell it what device we're using, -A. HackRF is what we're using in this case. What the frequency is, -F, 315 megahertz. And then we're going to send out a Gaussian signal, which is just a random signal. And then -X is going to be the bandwidth, 2EX. What's the Y is the waveform. You see it here. And we're going to select 10 and verbose. V is for verbose. Keep our fingers crossed and pray to the hacking guards that this works. And we're going to go out and just send out a Gaussian signal to try to be able to jam. So it goes here and says built-in heat sink types using HackRF, supporting sample types, setting up the antenna, set center frequency at 350 megahertz using frequency. Okay, press enter to quit. So it's running right now. It set the bandwidth modulation to Gaussian noise. So my HackRF right now is sending out just a bunch of noise to try to block signals. Those of you who are into physical security, I guess it's also cyber security, probably recognize that in some cases, certainly in the US it's true, that when a major political figure is speaking, the security around them jams all signals. So they jam all the signals around prime minister, president, what have you. And those devices are for sale, but you can only buy them if you're law enforcement. And I guess you actually can buy them. Yeah, you can buy them, but you can't use them. So you can buy them, but you can't use them. It's illegal to use them. I think they're still for sale. Essentially, what we've done is we've done what the Secret Service or whatever the particular security service does around every major political figure when they're speaking in public, is they jam the signals around them. Why is that? Well, because those signals can be used to, say, trigger a bomb. As we all know that many times these IUDs, as they were used in Afghanistan and Iraq and other places, are triggered by a radio signal. So what they'll do is they'll block all the radio signals in the area of the political figure. So that's essentially what we've just done. We have blocked the radio signals in our immediate vicinity so that none of them can transmit. Hopefully it's not blocking my Wi-Fi because Wi-Fi is a radio signal, right? And one of the things that we teach in the SDR class is how to block Wi-Fi. You can actually use an SDR device to basically DOS a Wi-Fi connection by simply doing what we're doing right here, except doing it at 2.5 gigahertz, right? Here what we're doing is we're set up next to a vehicle, maybe with an amplifier, and we're sending out a very, hopefully strong signal that's just a bunch of noise to block the fob from connecting to the car. Now, if the individual doesn't know that the car didn't get locked, they're walking away, they're going into the home, and the car never locked. They pushed the button, but the car never locked. So now our friends, Romero and Mobley, can walk in and they'll be inside the car. Now, that doesn't mean they're actually going to be able to start it, although many of these key fobs now have remote start. That is the next step. This is only going to keep them from locking the door. It's not going to start the car.
So how did you know which interface to use? Is there a command that shows you, like you can do IW-config to see a Wi-Fi adapter, or do you just need to know that's what it is when you connect it?
That's a good question. I'm not sure that there is a command yet one of the things you could do is do ls USB. Here's my Great Scott Gadgets HackRF. It just shows me all of the USB devices connected to this system. I don't know that there is yet there might be. If anybody knows it, let me know, but I don't know of a command that's going to show you just the SDR devices. In this case, this will show me all of the USB connected devices, and this is the one I'm using. And the reason that I'm using this, okay, just so it's clear, it's probably the least expensive and effective SDR device. Now, you can spend several $1,000s on SDR devices, right? You can spend a lot of money on them. There's some really high-end devices. The drawback to this one device, the HackRF, is that it's only half duplex, and so that's a drawback to it. If you want to send and receive simultaneously, the HackRF is not going to work for you. So in our case here, we don't want to go send and receive. We're just basically, in this case, sending. But if you had to send and receive, you're probably going to have to move into a more expensive device. The advantage of the HackRF is that, one, it can send and receive, but also that it covers a much broader range of the spectrum than, say, the RTL-SDR. It'll go up to 6 gigahertz. I've got them on the website Hackers Arise. I've got a comparison of all the SDR devices there. And you can look at the various specifications and the prices for them. But this is the one that we're going to be using in class. It's inexpensive, relatively inexpensive. I know $300 is a lot for some folks, but when you're talking about SDR and you're talking about being able to do the things that we can do with this device, it's really a small investment, especially when you start comparing it to the high-end devices that are running $3, $5, $10,000. Now, for just listening, the RTL-SDR is great. Okay, we used it to be able to identify where the key fob was transmitting.
And that's how you got your 3150 E6, right?
Exactly.
Like the X2, E6, Y10, that kind of stuff you just have to learn. It's like there's the waveform. You just have to know that. Is that right? Is that something you can just learn by taking your class or documentation or something?
From documentation, taking the class, either one or, or both, right? So the Y is the waveform. So here we got the X and the Y are the waveforms, the waveform frequency, and this one works pretty well for these key fob signals. Now, so that's simply jamming signals, and jamming signals can be useful. I mean, you might think of it as just like a DOS attack. A DOS attack is a very simple attack. What you're doing is you're simply just throwing out random stuff into the airwaves to be able to block a signal from being able to communicate. All right. Let's look at then an attack against what's called a replay attack. There's man-in-the-middle attacks you can do in TCP/IP, Wi-Fi attacks that allow for replay attacks. So what we're going to be doing is very similar. What we're going to do is capture the signal and then be able to replay it. There's a lot of different ways to do this, depending on what software you're using. Since we're using the HackRF and we're using the Dragon OS, it's pretty simple to do. If you're using some of the other software, basically what you have to do is record and then send. And once again, it requires a SDR device that's capable of transmitting. So if you're using the HackRF, we can just use a command line. Most of the other software devices are all kind of GUI based, but HackRF has some nice command line tools that make it straightforward and simple, all right, to be able to do this attack. So we can go transfer, okay, HackRF transfer, -S, and then the bandwidth comes first, and then the frequency, 315.500.000, and then we'll call this, we'll call it Mr. Robot. So what it's going ahead, and it's capturing the signal at that frequency. I'm going to stop it. So this is the command right here to capture what's going on at that frequency. This is the frequency that our key fob is working at. So once we've captured it, then we can go ahead and send it out. And that's what we're going to be doing next.
Does it say caught signal 2? That's where you press the button, is that right?
Yeah, that's where I did a control C. It says here, stop with the control C.
Did you actually press your button on your key fob and then capture it?
I didn't. I'm just showing
the
process.
Yep. Okay, yes. Yeah, no worries.
I could do it. Let's do it that. I'll do it that way. So let's go here and let's go ahead and send the key fob out. And so it's capturing my key fob now. Okay, I'm sending out the signal. Control C to stop it. And then now that I've captured it, it's pretty simple. I can just go -S. And then the bandwidth we want to send it out on, the frequency 315500000, and the file is going to be Mr. Robot -A1, and then we're going to send it out. Transfer with 24. Okay, it sent it out. And if the car was close enough, it would have opened the door. And of course, assuming that the vehicle is vulnerable to a replay attack. These are going to be on older vehicles and including Honda-made vehicles to about 2020. If you're close enough to capture the signal and then replay the signal in a vehicle that doesn't change the passcode, then you open the vehicle. On more modern more secure vehicles, they've gone ahead and made it a little harder to do, but it can still be done. So what they've now done is they put in like a rolling code. So the password changes each time the user clicks on the key fob. And the way that can be broken is that you have to first jam the first signal, because it sends two signals. Jam the first signal, capture it, and then when the user goes ahead and sets the next time, the next click through, the next signal, capture that. Those two signals together, you can go ahead and determine the algorithm that's generating the numbers, and then go ahead and essentially do a replay attack. It's a little more complicated. It takes a little social engineering, because imagine that if you were the person and the first time you clicked and you didn't hear the door open, you had to click again. So what you've now done is you've clicked it twice and your car still hasn't opened, maybe 3 times. You might start to wonder, but this is probably the best approach to be able to get into more secure vehicles with the rolling code. I recently was testing another car, and I'm not going to tell you what it is. I was testing another car, and it's sending out spread spectrum, which to me seems like the most secure technology. But I'm surprised that not everybody's using it. That's going to be a little more difficult to be able to hack, but it still can be done. It's just a little more difficult. And that's it's the whole thing of this chess game between security and hackers. The hackers develop a method to break a security, and then the manufacturers come up with a better security, and then they come up with a better way of hacking it, and then they come up with better security. So right now it looks to me like spread spectrum, which I haven't seen anybody else write about yet online. I may be the only one doing research in that field right now. I don't know. I don't know if anybody else is. But spread spectrum appears to be state of the art in terms of security. The BMWs and the Mercedes are all using this rolling code, which can be broken, okay, by basically jamming and then capturing the signal. And we'll give Sammy Kankar a shout out there, because he's the one who figured that one out. That technology is now being built into some of the new devices, hacking devices for hacking cars. Okay, so that's how to get in the door. Or maybe you can start the vehicle too. If they have an auto start, you can capture the remote start and be able to send it out. On many of these vehicles, the signal between remote start and door opening are very similar. Sometimes all you got to do is flip a couple bits in the signal and you can start the vehicle as well. In Mr. Robot, after they get inside the vehicle, of course, the vehicle's not running. We see Mobley opening up his laptop, and he connects the laptop directly into the ODB2 connector. ODB2 connector, I'll show you a picture of it, is the connector that's under the dashboard where, say, your mechanic will connect into the network. That's what it looks like under your dashboard. So your mechanic will go ahead, or you can too, connect into this with a device. You can buy them in an auto parts store for about $50, $100. And what it does is it connects into the network of the vehicle and will read the codes. So if, for instance, if your check engine light's on, and you got to go pay somebody to go find out, you can buy these devices for like $50 to plug into the ODB2 connector under your dashboard, and it'll tell you what's wrong with your car. It's not always, the end of the world. I mean, oftentimes those lights will come on just because a sensor has failed. But in any case, this is the ODB2 connector. That's what they're connecting to under the dashboard. Okay, so this is what he's using, 924. All he's doing is connecting his laptop to the ODB2 connector. And you can also get them that have Wi-Fi and Bluetooth, so you don't have to necessarily use a wire, and that allows you to do it remotely. But then once you're connected into the car's network, then all things are possible. Okay. We talked earlier in one of the earlier videos about SCADA hacking, and the SCADA networks are very similar to the car networks. They're different than what we're accustomed to using in terms of TCP, IP, and Ethernet. They're generally serial, they're lightweight, there's no authentication, okay, there's no encryption. Once you're inside the vehicle, then everything's available to you once you plug into the network. Now, some vehicles actually are using Wi-Fi to connect their networks from different devices. And so you may not even have to connect to the ODB2 connector. You might be able to connect right into the Wi-Fi and be able to do what we're going to do next. All right, so what we're doing is I'm going to show you a little bit of car hacking research. Let's go to my Kali here. There's a number of tools that you need to acquire to be able to do any research in car hacking. And most of these tools came out of research at Volkswagen, Volkswagen's kind of been one of the leaders in security research, although their vehicles are almost as susceptible as everybody else's. They've put together some good tools to analyze. So what we need are a number of tools that are called the socket can or can utilities, and we got to go ahead and download those. Let's go sudo apt install can-utils. Can is the name of the type of network that are inside of vehicles, right? So these are CAN utilities, or socket cans often referred to. These are simply utilities for working in the car network. Tells me it's already been installed. Imagine that. Okay.
You're prepared as always. Yep.
Now, if we've plugged into the car ODB2 connector like Mobley has, that's all basically we need to do. But in our case, we're not connected. We're some distance from a vehicle. So what we're going to do is we're going to run a simulator. And those of you who are into car hacking may be familiar with Craig Smith, wrote a book from No Starch Press called, I think it's called Car Hacking. Good book. It's a little bit dated, but he still has some good stuff in there. He put together a simulator. He teaches classes on car hacking. And what we're going to do is we're going to go ahead and grab it. It's in GitHub. And it's a great little tool for being able to learn how to hack cars. And so it's going to be sudo git clone HTTPS. You can go ahead and do your research and learn about the CAN network without having to connect to a car. You can see it's coming up there on the screen. He goes by Zombie Craig, and it's going to be the ICSim. I use this in my classes to teach people how to hack cars. It already exists, and it's not an empty directory. There you go. You've got the URL to be able to download it yourself. Then you want to go ahead and go to that directory. cd ICSim. We're in that. We can go to ls-l. You can see there's a setup for the vcan right there. So we got to run that setup. I've already run it. I'm not going to go ahead and run it again. There's a couple things in there. We have the controls, we have data, we have the ICSim. So what we need to do is just simply go and run our ICSim. And the vcan 0, which is basically a CAN protocol interface. So it's basically we've created an interface that can talk to the CAN protocol. That's what this setup vcan does right here. So now we're going to go ahead and start the simulator. Open Garages is Craig Smith's organization. Then go ahead and start the controls.
It's great to have this, though, because it means you can practice without having to have a car. Yeah, brilliant.
It's kind of a, if you've ever done this, sitting in your car trying to work, it's kind of it makes it difficult to have classes, remote classes, and it's not always the most comfortable place to be able to sitting with your computer. So Craig put this together, and it works pretty good. Now, there have been some issues with setting this up. Now, some of the make files, they just don't work with some of the newer versions of Linux. So when I run class, I'm going to be using an older version. This particular speedometer here, I can get the speed, I can get this thing to accelerate and do everything it's supposed to do, but it doesn't show up on the speedometer. There's something that isn't quite connected there, but I've got most of the other issues worked out with it. Let's see, no controls. I got to go to the right directory, cd ICSim. Then we can go and run the controls. And he's got it set up so it'll run off a game controller or your keyboard. And here's the game controller. It'll run off your keyboard as well. You use up arrow or right shift to do the doors. And then the last step is we've got to open up the cansniffer. Cansniffer. Now, what this is very similar to Wireshark, but it's for the CAN protocol. So what I'm doing here is simply saying cansniffer. I'm invoking the cansniffer. I'm starting it. I'm executing the cansniffer. And I'm telling it to use color. That's what the -C is for. And then I got to tell it what interface to be able to sniff on, vcan 0. And then run it. You'll see this on the screen on his computer in Mr. Robot. And what he's doing is that he is sniffing the CAN network. These are all the commands that are going across the network. The idea here, if you're doing research in car hacking, is that you want to identify what command does what. One of the key issues in doing research on vehicles, there's little standardization. The CAN protocol is standardized, but the commands are not. If you know the command to say start the vehicle in one vehicle, it may not work in another vehicle. that's one of the issues that you're going to face. I think the vehicle in Mr. Robot is it's a Chrysler minivan. I kind of watched it up close and zoomed in and see what it was. It's an older Chrysler minivan. So to be able to start the vehicle, they're going to have to know what the command is and then be able to essentially do a replay attack. So you capture and then replay, very similar to what we did with opening the door, right? We've got these commands. Each one of these is a command with data attached to it. We can go ahead and capture a command as it goes across and then replay it on the same network. And let me do that for you next. We've got this vehicle running in the background. We've got a sniffer running here. Now what we can do is that we can capture this traffic into a file. Candump -c -l vcan0. So we're sniffing on that interface. Now what we're going to do is that we're going to be able to grab that traffic and put it into a file. You can see it's creating this file right here. I'm going to go ahead and Control C. Now what I can do is go more, and let's take the name of this file, and I can view it. There it is. In doing research, what I would want to do is I would want to go ahead now and discover the commands that are going to control, say, the doors or the ignition. And I can do that by executing, say, speed up the vehicle or slow down the vehicle or open the doors, close the doors. By watching this traffic, I can determine what command is doing what. Once I know that, I can identify it. Say that I've gone ahead and determined that say, command 116, okay, or 161, I think is what it is on this particular simulator, actually accelerates the vehicle. Let's go ahead and search for that command, see if there are any. So I'll do more, and then I'm going to go ahead and grep. And I'm going to grep for 161. The command to be able to accelerate this vehicle is this one right here.
And you know that just by research, right?
Well, I've done it from research, exactly. I've done, it's kind of a tedious process, right? What you got to do is you got to accelerate the vehicle, watch the traffic, and keep on.
Yeah.
So rather than doing that on screen, I've already done the work. So this is the command and the data that will accelerate the vehicle. So what I can do then, okay, is go ahead and just send that command with cansend. So basically this is a replay attack. That's what it is. I've just captured the data, and then I'm going to go cansend. And then this is going to be over vcan0 161. It's just going to be this command right here. So I could just copy and paste it, right? This right here. By tedious research of watching, accelerating the vehicle, slowing it down, I'm able to identify what command accelerates the vehicle. Maybe I'm looking for what opens the doors. Opening the door is not is not going to be that interesting because we're already inside the vehicle. What we want to do is to be able to speed it up, slow it down, what have you. And maybe, you can do this remotely as well. So let's go ahead and send it on that network. So what we've done is gone ahead and sent a accelerate command into the network to speed up the vehicle. So that's kind of what automobile hacking research is like. It's kind of a tedious process. Once again, we don't have to authenticate ourselves. There's no encryption going on. Once we're inside and connected to the network of the vehicle, we can actually get inside and view all of the traffic. Think of this as like a Wireshark inside the network of the vehicle.
How realistic is the Mr. Robot hack where they open the doors and then start the vehicle and drive off?
The way I assess it is that they probably did a replay attack. Given that they're really close, you notice that the woman who's closing the doors is close by, and they could intercept and do a replay attack and open the door. The part that is more difficult to believe is being able to start the vehicle with the laptop, because like I was saying here, is you got to do your research to be able to determine what the command is. Now, maybe before they did this, they've got exactly that vehicle and they've figured out what that command is, which, you could do it in a couple hours, right? Maybe less, but you'd have to have the same vehicle because even the same manufacturers use different commands in different vehicles. Given that you know that, then you could have gone right into the vehicle and pushed a button just like I did there and said cansend, right? And started the vehicle. That's the part that's a little that stretches credulity is that they went into a vehicle that they never saw before, apparently. Maybe they did, I don't know. And they were able to start it with the laptop. That's unlikely unless they've done the research or somebody else has done the research and put it up on the internet and they would download it. There's not a whole lot of research online about car hacking. As you mentioned, Alyssa Knight has done a book and has done some research. Craig Smith has done some, and there's a number of others, but there's not that much information out there. Metasploit has now built car hacking into Metasploit, but they don't have many exploits in there. I'll just show you what they have. But the important point is that they've built in the capabilities of being able to hack cars into Metasploit.
Yeah, that might come later, right?
Well, they put it in, I think it was 2018. They built the capability in 2018, and Craig Smith has written that part. And I was hopeful, in 2018, there was going to be more coming. Apparently, there's not that much interest in car hacking, unfortunately. But we can go in here and see, I think they call it hardware hacking. Let's go hardware, search hardware. Yeah, you can see the scan the CAN bus for diagnostic modules. Okay, here's identify the modules. These are post exploitation, post. Once again, it's there's a hardware bridge you need to go ahead and put in. So to be able to hack the vehicle, you've got to basically simulate a serial connection in your laptop. That's the first step. You got to put in a simulated serial connection and then be able to connect Metasploit to that serial connection, and then you can go ahead and use some of these exploits. There's not a whole lot. Here's a Mazda 2 instrument cluster accelerometer mover, so it's going to change the accelerometer. There's another one that's an overheating a vehicle, I think. Here's a ECU hard reset under automotive. Maybe we just to do better search, just look at automotive. But yeah, they put it under hardware hacking. Here we go. There's 7 modules here. Here's a flood of the CAN. This is a new one. I don't think I've seen this one before. Maybe I just missed it. This is the pyrotechnic devices, the airbags, battery clamps. Basically, looks like it's going to start a fire in the vehicle. Notice that they're post, because they're assuming that you've exploited the network already. Some diagnostics, the entertainment control unit, hard reset. Here's the Mazda IC mover. Here's the CAN probe. Here's the Malibu overheat, and then identify module. So I think that Craig Smith has written all of these. Maybe I'll write some in the future and put them into Metasploit. We'll see. So I think it gives us a good idea of what they were doing.
Whenever we get you on for a presentation like this, if you like, or a demo like this, it's amazing how much you know. Thank you for sharing your knowledge with all of us. Thanks for doing all these videos and sharing.
Oh, of course. I enjoy doing this. So I'm ready and willing to come back whenever, David.
Please put below what you want us to cover. We've discussed some ideas, and one of them is like hacking an Android phone. I think the FBI Stingray type thing.
We were talking about doing in season 1. Elliot goes ahead and hacks the Android phone of one of the drug dealers who are in his house, and it's on a local area network. He connects to Elliot's Wi-Fi network, and Elliot then is able to hack his phone and get all the information out. That's a lot easier to do than being able to hack a phone remotely that's on a cellular network. So we'll do that one, and then we'll also talk about how to create a femtocell, which is essentially a mini cell tower that you can intercept all the cellular communication when people connect to it. There's a hack that Elliot does and his team does where they actually blow up the buildings. Elliot, has some regrets about, his involvement and basically crashing the global economy, but his team still goes ahead with this hack of the buildings that store all the hard data, the hard copies of the data, and to keep Evil Corp from being able to restore that data, they blow up the buildings. And they blow up the buildings by manipulating the uninterruptible power supplies. Now, that is a really common hack and very doable. That's the same route, by the way, that the Russians used to hack the electrical grid of Ukraine in 2014. They got in through the APCs. Now, we think of APCs as simply a battery, right? But it's a little computer in there. And so you can hack that. And there was just a brand new vulnerability found in those things just like a month ago. It's very doable, that hack against the Evil Corp where they blew up the buildings. We'll do that one too.
We've kind of mentioned it, but just to reiterate, you do the SDR stuff, you do a lot of this car hacking stuff. as part of your courses, right?
I do. I have the SDR class coming up in August, car hacking coming up in October.
Brilliant. So I've put links to those below. So if you want to sign up for the courses, then do that. You're closing registration on some of the options, is that right?
Yeah, we've had so many people sign up for the monthly program that we've got to close it down for right now. We may reopen it again, but right now we've just got too many students in that program.
Occupy the Web, thanks so much, and we look forward to having you back again.
Thanks, David. Good being here. See you all again soon.